Scatter plots may show positive and negative correlation.
All right, thank you, Jose. So scatter plots display data in two variables. That is your definition of scatter plots, so go ahead and highlight that. Okay? The data points are plotted on a graph to represent the data and determine correlation. Scatter plots may show positive, negative, or no correlation. So if you can look down in the middle of your page, you can see examples of what it's talking about. We have the data points on the graph, and these are trending upward. If you look to the right on the types of slope poster, what does a positive slope look like? It rises up. A negative falls down. Rises up, falls down. And no correlation, it's just there. Okay? The data is not related. So, positive correlation means that when one variable increases, so does the other. Negative correlation means that when one variable increases, the other decreases. I want you to underline the word decreases with your writing utensil. Okay? So positive is up and up. If I increase the amount of time I spend studying, I'm going to increase my grades. If I increase the amount of time I spend working out, I'm going to increase my endurance and fitness level. Okay? If one increases, the other increases. Negative correlation means when one variable increases, the other decreases. So, the more I drive, the less gas I have in my car. It's negative correlation, okay? So what we're going to do now, and no correlation means the data appears unrelated. So, jump down here, and we're going to write our definitions. We're going to match them to our graphical representations of those definitions. So, on a positive, you have one variable increases, the other variable increases. Okay, increase. With negative correlation, one variable increases, the other does what? Decreases, goes down. And then, with no correlation, data is unrelated. Give you a few minutes. All right, so jump back up here to number 1, and we're going to work through 5 examples. Oh, sorry, is anyone still writing?
No.
All right, let's look at these examples. First, it says height versus the weight of 100 male African elephants. So let's draw a picture of this scenario. I'll have a graph.
We don't draw it right now.
No, you don't have to draw this. I'm just making examples for you all to have visuals, okay? But if you would like to draw it, by all means, you're welcome to. So I have height on one axis and weight on the other axis. And let's say I have an elephant that's 3 foot, and maybe 5 foot elephants, some 7-footers, 9. Let's say their height goes all the way up to 11 feet. And I'll have increments of 500. So I'll have 1,000 pounds, 1,500, 2,000, and 2,500. Where is 1 ton? No, which one of these is 1 ton? It's 2,000 pounds. So just for your, when you see that one, you know that's a ton, okay? So if I'm an elephant and I'm between 7 and 11 feet tall, do you think I'm going to weigh at the bigger end or the smaller end? Right. My taller elephants are probably going to weigh closer to between 2,000 and 2,500 pounds. My mid-range elephants, 5 to 9 foot tall, probably going to be in here between 1,000 and 2,000 pounds. And my short guys, my little baby elephants, are probably going to be some probably less than 500 pounds, the newborns. So what type of correlation do we see here? Positive. So as height, this is what you do, right? Increases. Oh, y'all can't see? There we go. As height increases, what happens to weight?
Increases.
Weight increases. And you didn't really have to know too much about elephants to make a good prediction that the taller they are, the more they weigh. Why do you think they did this with elephants and not with people?
Because
We're not that
well, not necessarily.
Elephants are, throughout their life cycle, are elephants eating Takis?
Yes.
Are they eating Snickers? Are they drinking soda?
course.
Elephants are only eating the natural foods created for them in their natural habitat. So their weight is going to be proportional to their height. With humans, that's not the same. Okay, we can be like, I need a third breakfast, or and our height and weight aren't necessarily related. There's lots of people who could be shorter and weigh a lot more. There's lots of people who are taller and weigh a lot less. Okay, so this really is only a good example for the animal kingdom, where they eat based on what they need, because as humans, we just be eating, or at least I do. All right, let's look at the second one. It says distance driven versus gas used. So let's take a look at this. All right. I have gas, and distance. And your standard gas tank is going to be about 20 gallons. If you're driving some type of larger SUV, you might have a larger tank than that. You actually might have a smaller tank. A lot of newer cars have smaller tanks so you can get better gas mileage, because your car won't weigh as much, so it can go faster. And we'll use increments of 5. So we have 10 and 5, and of course 0. In distance, we'll have 100 miles, 200 miles, 300 miles, 400 miles. Now, when I start driving, don't I have a full tank of gas?
Yep.
So at 0, I have 20 gallons. But then I start driving. What happens to me as I drive? The gas level goes down. So by the time I have an empty tank, I'm probably driven about 350 miles, okay? What type of correlation is this?
Negative.
Negative. So we're going to write negative. And we're going to write as distance driven increases, the gas decreases. Okay. Let's look at our third example. The amount of time spent studying versus GPA. Okay, so I have a graph. I have time on one side, and I have GPA. Do y'all know what GPA stands for?
Yes.
Grade point average. In high school, we don't measure our grades by 60s and 70s and 80s. we measure them on the GPA scale. So you'll be talking about, I have a 3.0, or I have a 3.2, or I have a 3.5, okay? So if you spend 0 time studying, you probably don't have good grades. But if I spend 5 hours, 10 hours, 15 hours, 20 hours a week, my GPA, I might have a 1.0, 1.5, 2.0, 2.5, 3.0, 3.5. Typically, the GPA scales go to 4 or 5, depending on if you're taking advanced classes. So, if I'm not spending that much time studying, I'm probably having a lower GPA, right? Now, are there people who cannot even crack a book and walk in the test and make an A? Yeah. There are people like that. I've never studied for it. I have 7 teaching certifications, and I've never studied for a single test. I've walked into every single test and just took it and passed it. I'm dead serious. Like, that's like one of the things I'm able to do is take a test without studying.
Man, I still study and I fail.
Doesn't mean I know it. It's just
study and I fail.
Because it's about how to answer the questions, not if you know the material. I can read any test and pass it simply because I can eliminate the wrong answers. I know which ones are wrong. Just because I'm a teacher and I've made tests and I've been around tests, so I know what tricks they use to trick you. Like, oh, that one says always, and that's not it. Or if it says never, that's not it. You know, I'm just a good test taker. It's just one of those things I can do. In any case, there's also people who can study forever and what? Never. Still fail. Okay?
Hey, that's me.
Okay? So this doesn't hold true for everybody, but by and large, the more you study, what happens to your grade point average?
Increases.
It increases. What kind of correlation is this?
Positive.
Positive. As time studying increases, GPA increases. That's a positive correlation. Let's look at number 4. Hair length versus height of 150 adult women. So let me scoop this up. I'm going to have my hair length
Mine is medium.
and height. And let's say I have a woman who's 5 foot tall, 5'2", 5'4", 5 foot. Please turn your music off. You should not be listening to any music, and no one should have the Chromebook open. Guys, you're not paying attention. You cannot pay attention to more than one thing at a time. If you could, probably wouldn't be in here, okay? We need to focus on one thing. I kid you not. We should have a good 10 minutes at the end of the class period, okay? But if I have to stop and redirect, that's a problem. Okay? Y'all have done so well. I'm very proud of you. All right. So, let's say I'm 5 foot tall. Typically, how long is my hair?
Medium.
What about if I'm 5'2"? Typically, how long is my hair?
It increases. It's like.
Is an adult person's height related to the length of their hair?
No.
No, it's not. There are tall adults with short hair. There are tall adults with long hair. There are short adults with short hair. There are short adults with long hair. This is no correlation.
Oh, okay.
Okay? These events are not related. I cannot determine how long someone's hair is based on how tall they are. Now, what if I were doing this with little girls who are like, the oldest was 3 years old? Would their hair length be related to their height?
No. Yeah, kind of.
Probably, because do little girls that age cut their hair?
No.
No, so the older ones, the ones that are closer to 3 years old, probably have longer hair. And the younger ones, the ones that are like 18 months, they would probably have shorter hair just because they aren't as old and haven't been alive longer to grow their hair. But with adults, hair length is not related to height because we make the decision to cut our hair to, do things to it. So this is no correlation. There is no relationship between hair length and height, okay? So on your paper, you're going to write hair length and height are unrelated. And this is no correlation. There are 2 R's and 1 L in correlation. I apologize for not being on the screen. Our last example, distance walked in a pair of shoes versus the thickness of the shoe sole. If any of y'all come up like I came up, I had to wear them shoes so they was talking. Some of y'all don't even know what I'm talking about when I say shoes are talking.
When
the sole come away from the rest of the shoe and it's like, yeah.
Oh, right.
Yes. It is not a good look. So I have my distance traveled and I have my thickness of the shoe sole. So let's say I go 50 miles, 100 miles, 150, 200, 250, 300. And I start out with shoes that got 3-inch soles, and then we go down to 2.5. Now my soles are 2 inches. Keep walking, about to be 1.5. Keep walking, it's 1 inch, half an inch, and now I'm walking on the street. Okay? When I start out, my shoe soles are 3 inches, right? But as I walk, what happens?
It's going down. It's decreasing.
It decreases. They wear out.
They're
You start, the friction between your feet and the street, they wear them out. Just like with your tires. Tires don't stay good forever. As you drive, that friction wears them down. So what kind of a correlation is this?
Negative.
Negative. So we're going to write negative here. And we're going to write as distance increases, thickness decreases. Just like in real life, the distance you run increases, the thickness of yourself is going to decrease. Okay? So we have increase, positive, increase, decrease, negative, increase, positive. Unrelated is no correlation, and increase, decrease is negative. And I did not spell negative correctly there. Negative. Yeah, when I'm done. All right, flip it on the back. 2 examples that we threw. Hey, we almost there. I promise.
I'm sleepy.
Me too.
This one is making me sleepy.
It says, creating a scatter plot is easy once the graph is drawn. Practice. The data below shows the average test scores in California on the standardized reading and math test for 8 years from 1992 through 99. Create a scatter plot to display the data. Okay. So, in year 92, I have math scores horizontal, reading scores vertical. My math score is 32, my reading score is 38. So I'm going to go to 32 on the math side and up to about 38 and make a dot. It doesn't have to be exact. Okay? For 93, my math score is 40, my reading score is 39, so that's going to be right below 40 on your vertical axis. 94, my math score is 50, my reading score is 55, so that's going to be about halfway. Let's see, this is about 55 because it's 50 and 60, so it's going to be about right there. 95, 48 and 48, a little before 50, a little below 50. 39 and 46, a little before 40, a little above, well, this would be like 45, so a little above 45. 45 and 50, So I would go probably about here, up to here. 42 and 45, go here and up to here. And then 40 and 47, go over here and up to here. What type of relationship do y'all see here? Positive. So you're going to write positive in your blank. You're going to draw a trend line. Okay. And we could say, as math scores increase, reading scores increase. And let's go to our final example. It says, creating a scatter plot is more difficult when you must create your own graph. Practice. The data below shows the height and weight of 12 female students in Mrs. Phillips' first grade class. Okay, so again, when we're younger, our height and weight tends to be more proportional. Label the graphs so that the data fits the plot. Label the graphs so that the data fits and plot the points below. So we have our height and our weight, but we don't have the lines like the numbers like they do. So we have to create them ourselves. So if I'm looking at my height column, I have to make sure the range of numbers that I use accommodates all of the data. So what is the smallest number that you see for height? The smallest height number I see is 38.5. That's all right. The largest height number is 53. So I need my range of numbers to cover this. So I'm going to start with, let's say, 35, 40, 45, 50, and 55. So I know that all of my heights will be contained within this graph. And then for my highest and lowest weight, my lowest weight is 32, and my highest weight is 65. So for weight, I might want to use increments of 10 and do. Thank you. Thank you. So I would say that this one will be 30. And let's see. I will do 40. I'm going to do increments of 10 on this side so I can keep all of my data. 50, 60, and we know above that would be where we could put our 65. So let's look at Lisa. Her height is 44 and her weight is 47. So I go to 44 for height and about a little before 50 on the weight and make a data point. For Simone, my height is 50 and my weight is 57. So I go to a little before 60, make a data point. With Meredith, my height is 38.5, my weight is 32. Penny, 39 and 42.
Names are good, Penny.
That lady from Big Bang Theory.
I feel bad for that girl.
Sheila, the height is 41, the weight is 36. So I have 41, I have 36, yeah, halfway. With Tara, I have 45.5 and 49. Meg, 48 and 62. So she's going to be above 60. With Mara, I have 51 and 47. With Steph, I have 53 and 65. With Callie, I have 50.5 and 49. So that'd be a little, like right there. Cynthia, 46.5, a little after 45 at 52, a little above 50. And then Joy, I have 45 and 43. And then we're going to draw a trend line. Yeah. We have another positive correlation, right? So this is positive.
Miss, how many times do we have to do the same thing?
Like 6. 6 times a
You get
day.
bored of it?
Well, I don't necessarily get bored. I just try to improve every time I do it. So as
You can't see it.
height, I'm sorry. Thank you for letting me know. So as height increases, weight increases.